How's it going, everybody? Welcome to Math with Corey. Today we're going to be looking at an integral xe to the 2x dx, and we're going to use integration by parts in order to solve this integral. Let's do this now. All right, so most times, when I look at an integral, I want to think about, can I simplify, right? Can I cancel out an x? Can I maybe factor? In this case, there's no simplifying that can be done, really. So I'm going to have to think about another method of solving, okay? The second thing I usually think about is u substitution. U substitution, simple process. It applies to many integrals. It's really a great process, a great method of solving. But in this case, it's not going to work, okay? You'll see that it won't work, okay? So what about integration by parts? Let's use that method in order to solve this integral, okay? So the formula for integration by parts is integral u dv, right? That's my original integral, equals to u times v minus integral v du. Okay. So what I have to think about is, what am I going to make u, okay? And what am I going to make dv? Well, let's think. Whatever I make u, I'm going to take the derivative of, right? I'm going to find du. And anything I make dv, I'm going to find the antiderivative of, right? So that I find v, okay? Well, so what do I make u and what do I make dv? Well, you want to usually make u something that is going to simplify or reduce, right? Reduce. So if I make u x, okay, and then I take the derivative of x, that's going to be 1. That's great, right? That reduces quite nicely. If I were to make it e to the 2x, well, then the derivative of that is, 2e to the 2x. That doesn't really reduce. I'm still getting that e to the 2x, okay? All right, so let's make u x, okay? Let's make u x. And then dv is going to be e to the 2x dx, right? So u is x, and then the rest of the integral, right, dv, is going to be e to the 2x dx, right? Okay. So if I take the derivative of x, again, we said that would be 1, okay? And it's going to be dx, right? 1 dx with respect to x, okay? And integral of e to the 2x is going to be, let's see, e to the 2x over 2, right? That's the antiderivative of e to the 2x. Okay, that's great. And something that you also want to consider, right? You want to say that we want to make u something that reduces, that's great. But we also want to consider this integral here, okay? We want to make this integral as simple as possible, right? And in this case, if we make, right, dv e to the 2x, v is going to be e to the 2x over 2, that means it's going to be v e to the 2x over 2 times du. Well, du is now 1 dx. You're going to see, it's going to be a very simple integral, right? So that's something else you could consider, right? So the first thing you want to think about is, what do I make u so that it reduces, right, quite nicely? And then think about this integral as well. What do I mean? So let's write everything out, okay? So my original integral is integral u dv, so that's integral x e to the 2x dx equals u times v, okay? U times v would be x e to the 2x over 2, okay? So again, all I did was, excuse me, u times v, okay, minus, sorry for that voice crack, by the way, integral, it's going to be v du. Okay, well, v is e to the 2x over 2. I'm going to take that 1/2 out of the integral. So it's going to be 1/2 e to the 2x times du. Well, du is 1 dx. Okay, so that's just going to be dx. Wow, how great is that? Now look at this integral. Integral e to the 2x, that's a very simple integral. We've successfully assigned u and dv. Okay, this is great. Now we just have to solve that integral. So the hard work has been done. Let's finish the problem now. So this integral, okay, x e to the 2x dx equals, let's see, x e to the 2x over 2 minus 1/2 times. Okay, well, the integral of e to the 2x, we had done this before. It's e to the 2x over 2. And then I'm going to add some constant of integration. Can't forget that. Very important part. The constant of integration. Never forget it. Okay. Something that I could do if I wanted to, is, let's see, I could bring out an e to the 2x over 2, right? Because then this is going to be x minus 1/2. Okay, and again, constant of integration. Okay, so the hardest part about this, right, when students are first learning this, they have a hard time. What do I sign for u, and what do I make dv, right? In this case, we made u x because the derivative of that is just 1 dx. That's great, very simple. dv is e to the 2x, v is going to be e to the 2x over 2. We plug into our formula, u times v minus integral v du. We found that this integral here is going to be very easy because, again, we assigned u and dv appropriately, okay? And then we just solve from there, okay? We simplified, we took out an e to 2x over 2, and that was the process of integration by parts, okay? Hopefully this helped. If you guys have any questions, leave it in the comments below. Thank you for watching.